The purpose of this video is to introduce the Texas Instruments 83 or 84, 84 Plus, 84 Silver. There's lots of different names for them, and there are a few other variations for these Texas Instruments calculators that do the time value of money calculations. The one I'm using is a Texas Instruments 84 Plus, but again, if you have an 83 or an 84 Plus Silver, they work the same way. Now you do have to be careful because some of the TI graphing calculators don't have finance functions. So you've got to make sure it's got the finance apps on it for it to function well for this course. But the first thing we're going to do is go ahead and turn it on. And now you can see we've got a blank screen here. And when we go in to solve basic 5-key analysis with the Texas Instruments 83 or 84, we want to use our finance apps and go to what's referred to as time value of money solver. We'll be using some of the other time value of money apps or finance apps as well in other videos that I do in our time value of money chapter. But for right now, find the apps key on your financial calculator. Go ahead and press that. And you'll see it pulls up a little on-screen display with lots of different applications that you can use. We want that first one, finance. So we're just going to go ahead and select that, press enter. And now you can see it brings up a bunch of different finance applications. Now while there are 7 shown here on the screen, if I scroll down, there's a little direction pad here. And as I scroll down, you can see there's a lot more of them on there. So just keep going down until you find the one that you want. But right now we're going to start with the time value of money solver. That essentially activates our 5-key approach. So let's go ahead and highlight solver, press enter, and now you can see it's bringing up a little on-screen display with the 5-key approach as well as a few extra items. Now you can see our N for the number of periods, I% for the interest rate, PV for present value, PMT, which stands for an annuity stream. Anytime we have an annuity, we're talking about equal periodic cash flows, such as a mortgage payment or car payment or saving so much out of every paycheck towards retirement. Our future value, which is what our money is going to grow to over time. And then we've got this P/Y and C/Y. That's our periods per year and compounding periods per year button. Now notice here they're both set to a default of 1. That's set for annual. And as you change one of those, they'll both change. So let's say I want monthly. I want to change that periods per year to 12. Just use this directional keypad to get to the periods per year area. And I press 12. Now when I do that, and then I go back up to my 5 key, notice my C/Y also changed to 12. So that's going to automatically default to the same setting. And that's what you want 99% of the time. If you really want to change it, then you can go change your compounding periods per year or something different. But for the purposes of this class and 99% of what you're going to do in a real world scenario, those are going to be the same. We also see at the bottom there that payment, end or begin. And that's just for annuities. Do you want your cash flows coming at the end of each period or the beginning? Are you making that mortgage payment at the beginning of each month or the end of each month? And that doesn't mean is it July 1st or July 31st, but what that means is it before we've had time to accumulate interest or after we've had time to accumulate interest? Or if you're saving for retirement, are you saving at the beginning of each period so you have time to earn interest that period, or the end of each period so you don't earn any interest during that first time period? 99% of what we do in this class is going to be set for end of period. And you can see that's the default. If you want to change it, just move your cursor down, slide it over, press enter, and now the begin is highlighted. Now let's go back to end and set our calculator to 1 period per year. So we're just going to clear out that 12, put in a 1, and enter. Now we can slide up And we've got our 5 keys ready to go. Now let's walk through an example. You deposit $7,000 into the bank today and earn a 6.5% rate of return or interest rate. Now normally when you think of a bank deposit, it's referred to as an interest rate. It's a loan you're making to the bank, so they're paying you interest. But in class a lot of times we'll see other terms like discount rate. Often when we're solving for present value, our rate of return, while bonds and interest-bearing deposits pay interest rates, stocks, a lot of mutual funds, other investments, you're investing for a rate of return. You might also see a growth rate. For instance, a company had $1 million in sales 10 years ago. They've got $3 million in sales today. What's their growth rate? So that's effectively the rate of change from 10 years ago to today. How much are you going to have after 15 years? So 15 is our N, and we're solving for future value. We want to know how much we're going to have at the end. So remember our 5 keys. 5 keys are N for number of periods, I for interest, present value for what we're starting with today, payment, which is our annuity stream, and FV for which our money is going to grow to. Now while we don't have an annuity stream in this problem, it's still there on our 5 key approach, so we're going to make sure we zero that out. So let me just write down these keys. We've got our N, our interest, our present value, our payment, and our future value. Now here, our N is the 15 years. Our interest is the 6.5% rate of return. Our present value is the $7,000 that we're putting into the bank today. We don't have an annuity stream, so we're going to zero that out. And we want to solve for the future value. Now let's look at putting that into our financial calculator. Now right now our cursor is on the N there. We want that to be 15. So we just press 15 on our calculator and then use that directional pad to go down. Now we're at the interest. That should be 6.5. So let's put that in. And then again use the directional pad. Go down to present value. That should be 7,000. So put in 7,000. Again, directional pad, down, and now our payment. Remember, we don't have a value for 0, and that's what it's currently set at right now, 0. So just use down. Now we're at future value. That's what we want to solve for. Now note in your calculator here that solve is actually green, which means we're going to have to use this alpha shift here in order to solve. So when we get to solving, we move the cursor to what we want to solve for, press alpha, and solve, and we get negative $18,002.89. Just go ahead and write that down. And then talk briefly about that answer. Our $7,000 invested today, deposited in the bank, is going to grow to $18,002.89 15 years from now. But something interesting to note here, and that's going to be important as we move through 5 key calculations, is note that our answer came out negative. What's actually happening here is the calculator is trying to balance out those cash flows. So we actually did this from the perspective of the bank. The bank received $7,000 today. That was a positive cash flow. So in order to balance things out, the bank has to give back $18,002.89 at the end. If you wanted your answer to be positive, look at it from the perspective of the individual. The individual gave up $7,000, so that would have to be negative, and then your answer here would be positive. Now, positives and negatives don't really matter that much if we have only one non-zero input for our cash flows. Cash flows in the 5 key approach are the present value, the payment, and the future value. Here we have a non-zero input for present value, 0 input for payment, and we're solving for future value. So we've only got one non-zero input for our cash flows. Anytime we have two or more inputs in these values, then we have to be careful about the direction. If we had a present value and a payment, or a present value and a future value, or in some cases we have all three and we're solving for the interest rate, then we have to be careful about the direction of the cash flows. And we'll see some examples of that in a couple minutes. Now let's go to our next problem. You're saving for retirement and want to save $4,000 per year at the end of each year for the next 25 years. Assuming you earn an 8% return on your investment, how much will you have at the end of 25 years? So we're still asking for a future value here. How much are we going to have at the end of the time horizon? But one of the big changes is now we're looking at an annuity stream. And the key to identifying an annuity stream is looking for an equal periodic cash flow. Here, 4,000, it's equal per year. So look for per year, each year, every month, something like that, to indicate you have an annuity. Now again, we're still going to use the 5-key approach. So your time value money solver, have your interest rate, your number of periods, your present value, your payment, and again we're solving for future value. So if we go to our 5-key approach, now we're going to go up to n, and we want that n to be 25 years. So just 25. Use the down arrow. Then we go to our interest. Here our interest rate is 8%. So we plug that in as our interest. Down arrow. Now in this case, we don't have a present value. There's no amount we're starting with. So we've got to zero out the PV. So here we just press our 0. That sets up a 0 value for the present value. But now we have a PMT, $4,000 per year. That's how much we're saving. So we make that 4,000. Go down to our future value. And now note that it's saved per year. So we've got a 1 period per year. So our P/Y is 1. And we're saving at the end of each year. So we want to make sure our payment is set up at end, which it is. So now we're cursor's on the future value again. I'm going to go ahead and clear out what was there before. Just press this clear button, and now it's blank. And now I'm going to alpha solve again. So alpha solve, and now we get a future value of $292,423.76. Now let's change that just a little bit. And what we're going to change is now instead of starting without anything, we're starting with $50,000 already saved. So we start the 25 years and we've already got $50,000 set up. So again, let me just write down the 5 keys here. And our N is going to be 25. Our interest rate is still the same 8% that we had before. But now our present value is $50,000. And our PMT is the same $4,000 per year that we were saving in our previous example. We want to know how much we're going to have at the end of the 25 years. So we're solving for the future value. Now remember before I said if you have 2 or more non-zero values for your cash flows, present value, payment, future value, you have to be careful about the cash flow direction. And we've got that here. We've got a non-zero input for present value, non-zero input for payment, so we have to be careful about the cash flow direction. In this case, what's important is that they're both the same sign. We're saving the $50,000, we're saving the $4,000 per year. So we're giving up the $50,000 today, kind of setting that aside into our investment plan, and we're giving up $4,000 per year. So technically we want to think of those as cash outflows, and cash outflows are negative. Now you can do this problem and leave them both as cash inflows as well. Look at it from the perspective of the investment plan, which is going to get your $50,000 and get your $4,000 and then give back a certain amount at the end. But for this problem, let's go ahead and look at it from the perspective of the investor, make those both negative. Now the key here again, they both have to be the same sign. If one of these is positive and one is negative, you're going to get the wrong answer. Either both positive or both negative, because both cash flows are flowing in the same direction. So now we go to our 5 key approach again, and our N is still 25. Our our interest rate is still 8, but now we're going to have a different present value. So let's move the cursor up to the present value. Our present value is negative 50,000. So we can use this negative sign down here, not to subtract. Use the negative that's in brackets to change the sign. Make that negative 50,000 for our present value. And now our 4,000, I'm going to go ahead and clear that out because we want that to be negative as well. So again, negative, and then 4,000. So now we've got all our cash flows in. We're still at 1 period per year. We're still saving at the end of each period, so all these periods per year and payment set up are right. Now I'm just going to clear out that future value, and now alpha solve. Now you can see we get $634,847. So that extra $50,000 at the start meant we had more than an extra $300,000 at the end. We went from just under $300,000 to just over $600,000 as our future value at the end. Also note here, because my present value and payment were both negative, my future value came out positive. That's how much is available to me to receive at the end of the 25 years. Now instead of solving for future value, we're going to solve for the interest rate, our rate of return. So in this example, you're offered $17,400 in 8 years. That's a future value you're going to receive at the end of 8 years in exchange for $9,500 today. So you're lending $9,500 or investing $9,500 today. You're going to get back $17,400 8 years from now. What interest rate are you earning on the loan? So again, N, interest percentage, present value, payment, future value. But now we're solving for that interest rate. That's what we want to find. So again, go to my time value of money solver. Now my N is 8. Solving for the interest, so I'm just going to skip past that. My 9,500, and that's a cash outflow. I'm investing that or saving that today so that I get a certain amount back in the future. I don't have an annuity stream here, so I'm going to zero out the payment. And my future value is the $17,400 I'm going to get back at the end of 8 years. So that's my setup. Go to my time value of money solver. 8 for my N. Let's just move on up to the N. Clear that out. Put in 8. Go down. Clear out the interest rate. Oops. Just going to put an 8 back in there for now. That's the last one, so we've got to come back and solve that at the end. Our present value, clear that out, negative 9,500. No payment. Let's clear that out, make it a 0. And future value, remember, was positive 17,400. 17,400. Now scroll back up to my interest. Go ahead, clear that out. And now alpha, solve, and I get 7.85 or 7.86% as my interest rate. Now I want to do one little thing here just to show you something to watch out for. What if I, instead of making that present value negative, I entered both the present value and the future value as positive values? So I made that 9,500 present value, 17,400 future value. Now let me go up to interest rate and clear that out, alpha solve, and I get an error. What that's telling me is there's no interest rate which allows me to get 9,500 today and get 17,400. I've got to give up the 9,500 to get back the 17,400. So that's one way to know that you've messed up with the negative sign. Be careful. Anytime you have two or more non-zero inputs, you have to be careful about the negative sign. Now sometimes you'll get lucky like here and it'll tell you an error message. There are some times though where you have to be really careful because you can get a solution, it's just the wrong one. So always think of cash flow direction anytime you have two or more non-zero inputs for your three cash flow buttons on the 5-key approach. Our last problem that we're going to go to is figuring out a car loan. So now you're considering the purchase of a new car that will cost $25,000. You've got $5,000 available for a down payment. So that means you've got $5,000. You're buying something that's $25,000. You've got to borrow $20,000 in order to purchase a car. So you're going to be borrowing that remaining $20,000 at 3.9% over 5 years. And now we want to know what the monthly payment is going to be. A couple of key things here. One, monthly. Every other problem we've done up till now has been annual. This one's going to be monthly, so we're going to have to set our periods per year to 12. So we're going to need 12 for our P/Y. Second key thing, payment. A car payment is an annuity stream. It's an equal periodic cash flow that we make each month. So we're solving for the PMT. Now you want to be careful. Sometimes as people refer to a single cash flow as a payment. Here we know it's a PMT on our calculator because it's an annuity. It's the same monthly car payment every month over the life of the loan. Another thing we want to be careful about is this 5 years. Now before N has always been just the number of years, but really it's the number of periods. It was number of years because we're using one period per year. But now we've got 12 periods per year, so our N is going to be 5 times 12 are 60. We're going to have 60 periods now for this loan. Another thing that a lot of people will make a mistake on with car loans as well as mortgage loans is the present value. Anytime you're doing a loan, the present value is the amount you're borrowing. In this case, we're borrowing $20,000. The house cost $25,000, but we have $5,000 available for a down payment. So we've already got 5 of the 25. We only need to borrow the difference. We need $20,000. So now we can go to our financial calculator. Our N, we said, is going to be 60. Our interest is that 3.9%. Our present value is the $20,000 that we were borrowing. We're solving for the payment. And our future value is 0 because we have no future value. After we make our last monthly payment, the car's paid off. It's all ours. We don't have anything else to pay. And the other thing to remember is you need to set your periods per year to 12. So let's go ahead and get into our financial calculator. I'll remember last time we were at an error message, so in order to clear that out, I'm going to go to second, quit. I'll bring up the blank screen again. Now I can do apps, finance, time value money solver, and I've got my 5-key approach set up again on the solver. Now remember here, 12 periods per year. So let's scroll down to the P/Y, make that 12, and now jump back up to our N. Our N was 60. Go down. Interest was 3.9. Let's go ahead and clear that. 3.9 is our interest. Our present value is 20,000. It's going to be positive because we're receiving the 20,000 and we're going to pay back the monthly payment. Payment is what we're solving for. So let me just bypass that for now, get to the future value. Remember, my future value is 0. Periods per year is 12. Compounding periods per year is 12. Car payments are made at the end of every month. So now I just hop back up here to payment. Go ahead and alpha solve, and I get my value of negative $367.43. So that's my monthly car payment, $367.43 a month. Pay off the loan. After 60 months, I'll have made my last payment. Car's mine, free and clear. This video should have walked you through the 5-key approach for your Texas Instruments 83 or 84 style calculator. Hopefully you're comfortable with that now. And if you have any questions, please let me know.